Hey guys, I'm Sam, and today we're going to be proving some trig identities. So these are all the identities that you really need to know for the IB and knowing how to prove them. So we got your reciprocal identities, which is your sine and cosine, basically. So the reciprocal of sine is 1 over cosecant, and reciprocal for that. Reciprocal, that's how it works. So we got cosine 1 over secant, and secant just 1 over cosine. It's reciprocal. Your quotient identities, those are pretty much the same thing, just we're using tangent now. So we're using tangent and cotangent, one over the other, which is equal to each other. But also for tangent and cotangent, tangent equals sine over cosine, and cotangent, because it's the reciprocal, it equals cosine over sine. For the Pythagorean identities, we have sine squared plus cosine squared equals 1. And we have some others for just the non-basic for sine and cosine. So tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. And also your double angle formulas, which are a little bit different from the rest. Sine of 2 theta equals 2 sine theta times cosine of theta, and cosine of 2 theta doesn't really relate too much to sine 2 theta. That is cosine squared of theta minus sine squared theta. Anybody have any questions on the identities? Y'all good? Good, sweet. Where to start? I don't know. Let's look at this. Choose one side to work on, preferably the more complicated side, because that's the side that you're going to be trying to simplify and equal to the less complicated side. So you're going to want to translate everything into sine and cosine, because those are the simplest units, if you want to call it that, and use whatever permitted identities you want to isolate whatever is on the less complicated side. And if you're still stuck, try to convert into ones, and sine, cosines, and ones are where you really want to be to keep it simple. And some little common mistakes, you could miswrite identities because over here, there's a lot of them, so you could easily, for the Pythagorean, I'd say those are the most difficult. You could just easily put the one on this side and screw everything up. You don't want to do that. No. And then also, don't use algebra when you're doing proofs. Use the identities. So let's just try a little example. So let's try to simplify sine 2x times secant x. So does anybody know which identities we want to use to try to get these simpler? Yes, Lexi.
You'd want to use one of the identities that involve both sine and secant.
That is true.
Like,
Do you know which
sine,
one?
No, isn't there like sine equals 1 over secant? Or am I wrong?
Well, let's go back to.
wrong again.
Let's go back. Which one do you think would work? We
Oh,
had sine 2x times secant. And remember, where to start, you want to translate everything to sine and cosine. Keep it simple.
The double angle one?
Yeah, we got the double angle form for sine of 2 theta, which we could just make sine 2x. So we'll have this.
Why do we use cosine in it?
I'm sorry?
Why do we use sine and cosine?
Because that's the way it works. That's just double angle.
No, I'm just asking because like I'm thinking like.
I don't know how it derived.
No, but I'm like saying like, is it because it's easier to simplify using those?
You want to use this because that's like, if you see sine of 2x or 2 theta, this is the simplified version because you could do more with that and you could work with
I
it.
understand. Thank you.
Cool. So we got sine of 2x equals 2 sine x times cosine x, which was the double angle formula. And secant x, using the reciprocal identity, we have 1 over cosine x. So, does anybody know what to do next? Just to combine them to see it laid out a little better. Yes, Evan?
Do you divide by the cosine?
That is such a good idea. I think we should do it. So we will, technically, you could read it as 2 sine x cosine x times 1 all over cosine x. So we have 2 cosines. How convenient is that? We can just, boom, cross them out. And that leaves us with 2 sine x. Easy as
It's
that. Proving trig identities. Now let's do one a little bit more complicated. So prove tangent squared x plus 1 plus tangent x times secant x equals 1 plus sine x over cosine squared x. See, it looks really complicated, but let's use the same principles that we used for the simple proof last one. So what do we see here? What can we simplify for sure? What do we know? What just about tangent squared x?
We can do, isn't there a double angle with that?
Well, we can't use a double angle because it's not 2x, it's tangent squared x. But tangent, we know from the quotient identities, is sine over cosine, right? So why would that be any different if there was a square? So we could write that as sine squared x over cosine squared x. True?
True.
All right. Plus 1, we like ones. Very nice. Tangent squared, same thing as tangent squared x. We just make sine over cosine. Then secant x, what is that equal to? Does anybody remember?
1 over cosine?
There we go. So let's just see that written out. There we go. Simplified it a little bit. We're getting better. So what does anybody see what they could do for the next step?
Multiply by cosine.
There we go. I'm sorry, what'd you say?
Multiply by cosine? I don't know if we, oh wait, no, it's not. We
Not
can't
quite
do
yet,
that.
but you're on the right track. You're on the right track. So we see that this can multiply, so we'll just make it sine over cosine squared x. Is that fair to assume? So we have two fractions with cosine squared x on the bottom, right? Because this equals 1, we can just transform that 1 into cosine squared x over cosine squared x to make it very, very simple so everything has the same bottom of the fraction. So now we have it all with the same denominator, so we can just put them all on the same fraction, because it's adding, right? So now does anybody have any idea what we can do to simplify this? Anybody see any Pythagorean identities?
Ooh, I do.
Could cosine squared be 1 minus sine squared?
Or
Or
you
the
could
other
have,
Sine squared x plus cosine squared x equals 1.
there we go. So we could just have
Oh,
1
you're right.
plus sine x over cosine squared x. So does anybody know what they could do from here?
Nothing.
1 plus
That's
sine
it.
x equals
That's
something.
it.
No, you don't need to do anything else. This equals this. There we go. We're done. Boom, you just proved it. What? Okay, so why we learned trigonometric identities? Anybody have any clue
No.
No.
why we proved them? They never go away. They're your calculus fundamentals. They always come back, maybe not in technical proofs. It may be for proofs for the IB exam, but if you're working with trigonometry or anything like that, you're going to need to know these identities and need how to know how to manipulate them. And for real life application, can't talk, excuse me. You can use it for architecture or engineering. And as you'll see in a problem for the quiz, has one real life application. So you
What
can
is
try
it?
that out.
How?
It talks about a block on a ski slope. Angle.
Is this
Just
what architects do?
take the quiz. Take the quiz, you'll understand. So one simple last proof, right? You guys think you do this just to collectively as a class? You guys stay with me? Alright, awesome. So cotangent, what can we translate that into?
1 over tangent.
That's true.
Cosine over sine.
Or?
Yeah, that's your answer's right. That answer's just a little bit more simple because we want to translate things into sine and cosine.
Okay.
What about cosecant?
1 over cosine.
1 over
Over
sine.
sine.
Over sine. There we go.
Yeah.
So that equals we're gonna use this side because it's the less complicated side, and there's really nothing to manipulate with that. So we have cosine x divided by sine x divided by 1 or over 1 divided by sine x. So we're just dealing with division for fractions now. So we
Sine
just
Just cancel.
multiply and flip it. So now what are we gonna do?
Cancel the signs.
Cancel out the signs because they equal 1, so like you just cross them out, yeah. So then we end up with cosine x divided by 1, and that just equals cosine x, which is what we're trying to prove. So give yourself a big check mark. There you go. Anybody have questions?
Oh, I put that there.
Oh, I like that. It's like a little GIF.
Yeah. It is good. And
You'd
then
be a
in-
great teacher, just saying.
You're very animated.
Yeah.
I
Thank you so
think
much.
I think your theater classes have really improved your
They really
speed.
do.